Okay, today we're going to look at another type of chemical reaction. This one's called single displacement. It's also called single replacement. Depending on which book or which resource you look in, you'll see both of those terms. They mean the same thing. And typically what you'll find with this is it's when we have a single element by itself, and then we have a compound. Okay, now sometimes this element is reactive enough to be able to go in and kick something else out and take its place. So that's what we mean by the word replacement or displacement. Is a single element is going to go in and take the place of something else. Now the trick is to know what does it take the place of. So if I look at these two examples, I have straight aluminum metal, it's pure aluminum, and then I've got iron 3 oxide, which you guys would know as rust. Okay, if your bike rusts out in the rain, it's iron oxide. It's this form of iron oxide. If I were to force aluminum to react with iron oxide, aluminum is going to want to go in and take the place of the thing that is most like it. Okay, it's going to want to kick out something that's like it. And in this case, we're talking about a metal kicking out a metal. So aluminum goes in and it replaces the iron. It kicks the iron out by itself. So what we're left with now on the other side of the reaction, once the reaction is done, now aluminum is with the oxygen and iron is by itself. So iron is now neutral metal. I no longer have the Roman numeral 3 there because Roman numeral 3 would say it has already lost 3 electrons, and that's not the way it is. Once it gets replaced, it takes its original electrons with it. And aluminum is now with the oxygen, so we would write aluminum oxide. Now, we've been working in class on how to write this properly with formulas. So let's remember a couple of things. Pure aluminum and pure iron are just single atoms, they're single elements from the periodic table. So I'm going to write aluminum, and I'm going to write iron. They're symbols for it. Now the compounds, when they go together, they trade electrons, and we have the charges to worry about because these are ionic compounds with a metal. So this is a +3, and if we look up oxygen, it's a -2. This is stuff we would look up on our periodic table. That means I need 2 irons to combine with 3 oxygens. This is what rust looks like. Fe2O3. Now on the other side, we don't worry about this 2 and this 3. If they end up over here, it's completely by chance. It has to do with how these elements will react with each other. Okay, aluminum, it wants to lose 3 electrons just like iron. It happens to be very similar to iron. Oxygen wants to gain 2. So we're going to need 2 here and a 3 there. This becomes Al2O3. And you can see kind of the scheme of how this looks. You have a single element, it goes in and kicks this other element out, and now they flip-flop places in this. Okay, take a look at the balancing here. We have 1 aluminum on this side, we've got 2 aluminums on that side. So I'm going to need to put a 2 in front of this, and now my aluminums are balanced. Let's take a look at iron atoms. I have 2 iron atoms over here, so I'm going to need a 2 right there to balance those iron atoms. And then I count my oxygens, there's 3 on the left, and there's 3 on the right. Okay. And that would be an example of a single displacement reaction. Now let's take a look at what this actually looks like. I'm going to use aluminum foil and rust. Okay, 2 things you've come in contact with before, but I'm going to have to force these to react. I've got these 2 old shot puts, okay, and they're made of, this one's pure iron, but you can see it's got some rust spots on it. Okay, it's been sitting out and it's just rusted over time. I covered one with aluminum foil, just the same stuff you would have in your kitchen, nothing special. When I get them to touch each other, nothing happens. I need to add some activation energy, and I need to try to get as many of these atoms to combine as possible. So I'm going to try to scrape them and smash them together, and sometimes that's enough energy just to get this going. So I'm going to find a good rusty spot. And what you notice is a big spark flies out. There's a lot of energy transfer during this reaction. And I'm actually forcing the aluminum to go in and kick the iron out. Let's try that again. That was a pretty good one. Okay. Could you do this at home? If you had pure iron that was rusted, you could. Okay. If you have steel, steel has a lot of iron in it, but it's not just pure iron, it has carbon as well. It doesn't tend to work as well as this. So just make sure, if you do try this at home, you be very, very careful in that a lot of aluminum and a lot of rust molecules, when you put those together, you may get a huge reaction. Sometimes it's small, and sometimes it's not. Okay? And that's an example of a single displacement reaction.